Hello, everyone. Welcome back to Deep Coding. In this session, we're going to talk about make the string great. In this problem, you're given a string s of lowercase and uppercase English letter, and you're looking for two adjacent characters, si and si plus 1, in this string, such that si and si plus 1 are showing the exact same character, English letter, English alphabet, such that one of them is lowercase, the other one is uppercase. In that case, you want to delete both of these characters in this string and continue doing that until you cannot find any two adjacent characters that meet this criteria. To solve this problem, let's take an example here. A, B, A, C. We are proposing to use a stack. At the beginning, if it's empty, I just fill my stack. But as I'm moving on, let's say I'm getting to A, what I need to do is check this if this A is same as top of the stack, but one of them is in uppercase, the other one is lowercase. In this case, top of my stack has B, but I'm looking at A, small a, or lowercase a, so I just push it to my stack. But when it comes to capital A, and lowercase a, which is top of my stack, are basically the same character in English, same alphabet in English. So what I need to do, instead of pushing capital A or uppercase A into my stack, I need to pop my A out of my stack, then move to the next, character, and then push C back in because C and B, top of my stack would be B. C and B are two different characters. And then at the end, I continue popping out and get BC. But pay attention here. I'm going to show it in implementation, but pay attention here. When you're popping out, C would be coming out first, then B. But you need to reverse it, then go to BC. But keep that in mind. How can we find out if two characters, A and A, as we saw here, are pointing to the same English letter? We're going to use ASCII number. The difference between ASCII number of lowercase and uppercase of the same letter in English is 32. If you go to ASCII number table and take a look at A, capital A, and lowercase and uppercase a, you see the difference would be 32. And would be the same thing for B, C, D, all the way to Z. So what we need to do at the beginning, if the stack is empty, I just push the first element in. And then as I'm moving on, if the top of my stack is the difference between ASCII number of top of my stack and the incoming character, incoming alphabet is 32, then I'm sure one of them is uppercase, the other one is lowercase, and I just need to pop it out. Let's code this one together. So I need to create a stack of characters and go through each of the characters in my string. If my stack is empty, as we talked about, that's just for the initialization. If my stack is empty or the difference, the absolute difference of the ASCII number of top of my stack and the incoming character is not 32, which means those are two different alphabets. Those are two different characters. Um, I just need to push it into my stack. Otherwise, instead of push that incoming character into my stack, I need to pop the top of my stack. So I just pop it out. And that's it. After I'm done with this iterating through my string, I have uh, a stack that has some element into it, which does not have this characteristic defined by the problem. So that's the answer. But all I need to do is to take out each of the elements out and then reverse it, then return the answer. So I do while this stack is not empty. Let me create a string, which would be my result, string result. And at the beginning, I just define it empty. Um, res plus equal stack dot top, the top element. And then stack dot pop. We just get rid of the top element. When we are done, I need to reverse my string and then return the result. Let's run it together to see if it works. Again, on those three examples, it's working fine. Lead code, these two E will be deleted, but these two won't because they are, although they are pointing to the same alphabet letter, English letter, but they both of them are lowercase. So it doesn't meet the criteria that one of them should be uppercase, the other one should be lowercase. And let's submit this solution. Accepted. So this problem, the time complexity is big O notation of n, where n is the number of characters because we're going through each of the characters. And the space complexity is n because in worst case, we're saving every element, every character in my string into the stack. So we're basically, in worst case, taking up to n elements into my stack. I hope you enjoyed this video. Until next time, thanks.